So good morning everyone. So today we are going to discuss about a topic called binary heap. So I will be explaining about the binary heap. So let's see what is binary heap. So before knowing binary heap, we must know what is priority queues, because binary heaps will be working on the principles of priority queues. So a priority queue is a data structure in which each element is assigned a priority. So in a data structure, each and every element will have some its own priority, and the elements which have the highest priority will be accessed first will be processed first, and the one which have the lowest priority will be processed last. And moreover, it depends on how you want the result. So in some cases it may be that uh, uh, you want to process the lowest priority elements, so you can process the elements which have the lowest priority. So it depends on the application to application. So this is about the priority queues. So let's see about some other things. This is binary heap. Now come to the binary heap. So what is binary heap? So it is basically a data structure to store the data in a binary tree manner. And in this binary tree, the root elements or root node will have the highest element for the max heap and the lowest element for the min heap. So we will see the one by one with examples. So here it is written that if B is a child of A, then obviously A is the parent of B, and A will have the highest elements. The value of the A will be highest. So this is example for max heap. So priority will be highest for the root element, and it has two properties. One is structure property, another is heap order property. A heap is a binary tree that is completely filled, with the possible exception of the bottom level, which is filled from left to right. Such a tree is a complete binary tree. As we know that what is a complete binary tree. So we will be processing from the left to right, and we have to fill from the left to right. So some by using we have some conditions are there, we have to fulfill that, and until and unless your heap property, that structure property is not achieved, so you cannot build a binary heaps. And another is a heap order property. That means if we are going to build a max heap, then definitely the parent value, that means the value of the parent node or the root node, should have the highest value, and for the min heap, the value of the root node should have the lowest value. So let's see with the examples now. So let's take, this is a binary heap. So here we can see that in this min heap, this root node has the lowest element, and this 6 and 12, these are the child nodes of this root node. So here this has the lowest values compared to your this root node. Okay, and this is the representation in the memory. This is the memory representation using some kind of one-dimensional array we can see. So each and every element will be stored in the memory locations. Okay, and this is about example for max heap. So in this max heap, see here the root element will have the highest value. That means the priority of the root element will be highest here, and here in min heap the priority of the root element will be lowest here. So in some applications, suppose if we want to process the lowest element priority first, then we should go with the min heap data structure, and if we want to process the highest priority, then we should go with the max heap. and for this deletion and all, and for accessing the maximum value, it will be easy by using these binary heaps, max heap, because we know that always the highest value will be stored in the root element. So directly we can access the root element here. And come to next is by this insert and delete makes are the basic heap operation. We can insert in the heap data structure, we can delete also the maximum minimum value, and other max heap operations are get max, extract max, delete. All these are the things that we will see with examples one by one. And see here how to insert into a binary heaps. So add the new value at the bottom of your heap in such a way that it is still a complete binary tree. So while adding or inserting any new element, you should always insert from the bottom level. So this is a bottom to top approach. So while inserting, you have to take care one property that is called the structure property. That means if you insert any element, that should preserve the complete binary tree properties, okay, as well as that heap order property. So if we want to insert the max, we want to build a max heap, that means the value which you have inserted at the bottom should have, if that is the highest compared to your parent, you have to compare it, then you have to percolate up. That means you have to move up, you have to keep on comparing until and unless it should placed in each correct order, and let the new value rise each appropriate place, each percolate up. That's what I have discussed, and this is the example. So here we are going to insert this 99 here. So 99 has been inserted here, because see here we have to process from left to right. Now this has we have to insert from here, but it's not like that the 99 should be inserted here, then that is wrong. We have to always process from the left to right. We have to preserve the structure property, complete binary tree. That's why it is processing from here. So next 99 will be inserted here. Now compare with the each this one parent element. Now if we compare, this is greater than its parent, so it will be swapped. That means this will percolate up here and 27 will come down here. See here. So this is a simple example. Again, this 99 will be compared with each parent. So this 45 was lesser than this, so 99 again percolate up. Again this will be compared with this. Now this 99 will go up. So this is all about your max heap. And here these are the algorithms of this binary max heap. So you can implement by doing some programming language, by looking this algorithm, and this algorithm is what we have already discussed, I have told. So just go through this, and this is all about binary mean heap. This is for binary mean heap algorithm, and this is algorithm is for max heap. And for today's session, that's it. Thank you.